we have two square root functions. One is always concave down, one is always concave up. I would like to do a compare and contrast regarding their concavity. Let's start with the one on the left. We have f of x equals to the square root of x minus 1. First of all, we have to figure out the domain of the given function. So since the square root of negative is undefined, I have to make the radicand x minus 1 greater than or equal to 0. So you can include a 0 because the square root of 0 is equals to 0. Okay, so to study the concavity, we have to go down to the second derivative. So for the first derivative, let's match the color. Let's do blue. So f of x prime of x, so we bring the 1/2 down, and then x minus 1 raised to the negative 1/2, and then by chain rule, when we take the derivative of the radicand, that is equals to 1, which doesn't affect anything, and then second derivative, so take another derivative, so this time we bring the negative 1/2 down, so we have negative 1 over 4, and then x minus 1, 1/2, negative 1/2 minus 1 is negative 3 over 2, and then the derivative of the linear function, which is the radicand, x minus 1, that is equals to 1, and then that is equals to negative 1 divided by 4 times the square root of x minus 1 to the third power. Okay, so this is the second derivative, and then to find the critical numbers, we have to set that equals to 0. How come we don't set the first derivative equals to 0? Again, so we have the given function, first derivative and second derivative. When you analyze second derivative, you are analyzing the concavity. When you are analyzing the first derivative, you are analyzing the slope. So the first derivative is for you to find the relative maximum and relative minimum. For the given function, every time you plug in a number to the given function, you get the location of a point on the curve. All right, so you have to set the second derivative equals to 0 because we are analyzing concavity. And then what can we say about the domain of the second derivative? Because we have to be careful when we set up our test intervals. So we have x minus 1 in the denominator. So first of all, x minus 1, I don't want to have a 0. So x cannot be equal to 1, right? Does that affect anything? Yes, that affects something because the domain of the given function is greater than or equal to 1. And then for the second derivative, you say that x cannot be equal to 1. So that affects the domain, right? So you cannot pick x equals to 1. Okay, what else? Also, since that is in a square root, you have to make sure that there is no negative, right? I don't want x minus 1 be negative because when you take the third power of negative, you still have negative, right? If x minus 1 is equals to negative 5, we have a trouble because the third power of negative 5 is negative. I cannot take the square root of negative. So therefore, you have to make sure x minus 1 greater than 0 and x is greater than 1. So overall, when you set up your test interval, you have to make sure that x is greater than 1. But do we have any critical numbers? I just point out the restriction, but what are the critical numbers? Do we have any critical numbers? The answer is no. There are no critical number. You have a negative 1 divided by a quantity equals to 0. No 0 is allowed in the denominator. So therefore, if you just let the second derivative equals to 0, there are no critical numbers because we cannot solve for x, right? So we cannot solve for x, but we can point out the restriction. Negative 1 is not equal to 0. Just listen to this. Negative 1 is not equal to 0. So negative 1 divided by a number won't give you a 0. So that means there are no critical numbers. So when you set up your test interval, you draw a number line. And then here is your 1. And we have to block off everything less than 1, and we cannot take 1 as well, so we have to be careful. X cannot be equal to 1, so we can take 1 to pass the infinity. So that is your test interval, and then you pick a test value. So let's pick x equals to 2, and then you plug it into the double prime. So f double prime of 2, what is that equals to? That equals to negative 1 divided by 4 times 2 minus 1 to the third, which is 1 to the third. So you have a negative 1 over 4, right? So you have a negative 1 over 4. That is negative. What does that mean? Negative means concave down. So that is what negative means. So negative means concave down. And then there are no inflection point, right? Because we don't have a down to up or we don't have up to down. So it's always concave down. So there is no inflection point. So the graph is concave up the entire time. If you want to take a look at the graph, so the graph is right here. So it's x square root of x minus 1, right? So you shift 1 unit, you shift the square root function 1 unit to the right. And then this is the graph of the square root of x minus 1. Always concave down. So the graph is concave down the entire time. All right, so let's move on to the next one. The next one is concave up. We have a similar function, except that we have a negative in front of the entire square root. So as a result, what's the graph look like? The graph looks like this. It's also shift 1 unit to the right, and the graph looks like this. So this one is always concave up. Let's do the math. So f prime of x, that is negative 1/2, right? There is a negative in front, so negative 1/2, and then x minus 1 raised to a negative 1/2. The derivative of the inside is equals to 1 by chain rule, and then double prime. So we have to bring it down, so that becomes a positive 1 over 4, and then x minus 1 to the negative 3 over 2, and then the derivative of the inside is equals to 1, so we can just go straight to the next step. The next step is 1 divided by 4 times the square root of x minus 1 to the third power. And then you set that equals to 0. So just like the previous one, you have to point out that x minus 1 cannot be equal to 0. So x cannot be equal to 1. And then what else? And then other than that, we have to point out that x minus 1 has to be greater than 0, because once we get a negative, you take the third power of negative, you still get a negative. So as a result, the square root of negative is undefined. So x is greater than 1. So since we cannot solve for x, then there are no critical numbers. So similar to the previous problem, we have a test interval. Let's save some space. So let's push the line a little bit up. So this is a 1. So 1, right? And then we block this off because we don't want anything less than 1. So the test interval is from 1 to positive infinity, and our test value is x equals to 2. And then f double prime of x equals to 2, because we are analyzing the concavity, so you have to ask the double prime. So double prime, we have 1 divided by 4, and then square root 2 minus 1 to the third power. So this time is positive 1 over 4, all right? The top is a positive 1, and then that is greater than 0. Greater than 0 second derivative means the function is within this interval. Within this interval, the curve is concave up the entire time. So it's concave up the entire time. And also, there are no inflection point. So it is possible to get a function where the curve is always concave up and there are no inflection point and no critical numbers. All right, so that is the end of this video. If you think my instruction is helpful and clear, give me a like. Feel free to share this video in any social media for me. If you are new to the channel, take 2 seconds to click the subscribe button for me. Thank you for your support. I will see you all in the next lesson. Signing out.